welcome to my presentation. It's going to be about high-performance Hibernate. Well, first a little bit about myself. My name is Vlad. I work as a developer advocate, actually much more of a developer than an advocate for a Hibernate project. You can find also my blog, vladhalcha.com. There are over 100 articles about Hibernate, and not just about Hibernate, about relational databases, enterprise systems, Spring, and more. And my Twitter handle, if you're using in my GitHub ID. This presentation is somehow based on my book, High Performance Java Persistence, a lot on the second part of the book, which is dedicated to Hibernate. For today, we're going to talk about performance and response time, and give a definition for those. And also, we're going to go through some things that you can improve in Hibernate when you have a Hibernate application, like connection management, identifiers, the relationships, batching, fetching, and caching. Okay. So, related to performance, this code is from Application Dynamic. They're building some application monitoring tools, and they realize that half of application performance problems originate in the database. Not just the database, not just the database that's to blame. It's actually the data access layer, which if you combine both of them, you usually get either good or bad. So you should treat them together, of course. Now, related to performance, why do you want performance? Is because it affects business. Because, for instance, like for example, in this code that was given by Google, and they said take into consideration also the side of the your site. So actually, if you have competition, actually you want to be faster than your competition, because usually Google is going to place your site is going to be a better ranking, and you'll see in the first results. And also because, for instance, Amazon, for example, this quote is from Amazon. They said that for every 100 milliseconds of latency, they get 1% of profit loss. So yeah, if you, in this sense, especially if you have a startup, you want to have a site that's responsive and that's usable, and it's very nice for the user, because that somehow is going to affect the business and the revenue of your application. So from this perspective, it's not just one technical thing. In a way, it has it affects business as well. Okay, so now before we start to talk about performance, we have to define where we put our boundary for our systems, because you can measure the response time on every layer, on every boundary, like for example on the web layer if you want, or on the browser side. But for this discussion, we can take into consideration the transaction manager, and the service layer. So that's why if we put and we measure there the response time, we will see what, for example, a transaction is going to be built. So actually, what happens when you use a relational database? First, you need to obtain a connection, which this process can take time. Then you are going to prepare and execute statements. We can optimize those as well, as we will see in this presentation. Then you will get a result set, which if you traverse and navigate, you can do it in a way that's going to be faster. And also, one thing that some people don't take into consideration is the idle time, when you already have the connection, but in the same time you don't release it because you're doing some application level processing. And if that takes a lot of time, you're going to lease the connection for that particular time, and other threads will not be able to use that connection. Okay, so the response time at the transaction layer can be summarized and can be built out of several segments. So you have the time it takes to acquire the connection, the time it takes to submit the statements, to execute them, to get the result, and then that time to do the processing before you release it. So we will go and discuss about those in the presentation, and hint which particular aspect optimizes what part of the response time. Okay, so now we can go to connection providers. Well, when you obtain a connection, without a connection to the database, you cannot do anything. You have to have it. But for example, the reason why we're using a connection pool is because fetching a connection from the database takes time, because that implies opening a TCP connection. It implies using a socket factory, a socket on the database side, and doing this handshaking TCP, allocating buffers and all sorts of structures, both on the server side and on the client side, and that takes time. And for example, if you measure how much time it takes for several databases, you will see that the time varies, but you can measure it in milliseconds, which is a lot. For instance, on one database, it takes around 50 milliseconds to get a database connection, which is quite a lot, because that means that in 1 second, you can only execute 20 transactions per second for one connection, which is pretty low. It's very low throughput. So that's why. But on the other side, if you're using a connection pool, like the last column in this table, which is one of the fastest connection pools available in Java, called Hickory Connection Pool, you will see that the response time for fetching a connection drops significantly, and it only takes like 10 microseconds. Below that, it doesn't even really make sense to optimize it. So it's extremely fast. When you're doing optimization, you're just pushing the bottleneck from one side to the other. In this particular case, it's improbable that the connection manager is going to be a problem for you. Another good aspect about connection pools is not just about the response time, but also about leveling up traffic spikes. Because if you don't use a connection pool, and for example, you have a traffic spike, the traffic spike will consume all the connections, and which will not be available for other processes or nodes of your application. So actually, the system will go to a halt, and you don't want that. That's why you want to give, because the number of connections is limited by the resources that you have in the database server, you need to provision those in such a way that both front-end, back-end processors, and all sorts of nodes you have in the application have dedicated numbers of connections. And in Hibernate, you have an abstraction called Connection Provider, and you have several choices to choose from. You can choose, for instance, the least, the one that's only designed for testing is the Driver Manager Connection Provider. You also have the C3PO, the Hickory Connection Provider, which offer a much better connection pool implementation than the one offered by the Driver Manager. But all in all, you also have this Data Source Connection Provider, which is the one that you can use with JTA or also Resource Local. Which one is better to use among all of these is actually the Data Source Connection Provider, and the reason why you should probably always use that is because it gives you the flexibility of bundling as many proxies as you want. Because from the application perspective, the application only sees a data source. It doesn't know what's behind that data source, but then you can just mix, and you can have, for instance, choose whichever connection provider you want, the fastest one, or the one that's most appropriate for use case. For instance, you can have Hickory Connection Provider. Then we see there the data source proxy. That's an open source library available on GitHub, which, for instance, gives you very nice logs, statement logs. You can see both the statement, the parameters, how much time it took, if it's a batch or not a batch, and you can even customize it and, for instance, do really interesting stuff with it. And also, FlexyPool, the last one, is a tool that I wrote for monitoring connection pools. But from the application perspective, it doesn't matter, it's just data source. So this gives you a lot of flexibility. Not to mention that you can vary and offer resource local or JTA transaction, and from the application perspective, it's going to be transparent. Okay, so now we have this connection pool, but now one very important thing to have in mind is this problem of provisioning the connection pools, because as I said, the number of connections in a database are limited by the resources you have, and you don't have a lot of them. I've seen, for instance, in some applications that I reviewed, pools that were set to 200 connections. That never works. It doesn't work like that. You barely have, for instance, if you're having a 32 processor database, probably you have 64 or 100 connections that it can deliver per node. So for instance, you have a master and multiple slaves, so you have a limited number of connections. But then how do you split those among multiple nodes? And you might even have auto-scaling from front end and batch processors that can run, like for example, to import data, to send emails, or for indexing the full text search that you're using. All those nodes require connections. So what can you do? How can you tell how many connections can you give to one node or to the other? And that was a very interesting thing that we need to solve in one application that I was involved when I was working as an architect, and I searched the internet to see if what I can use. Actually, there was nothing available, so I wrote this tool, which is called FlexyPool, and it supports almost all connection pools, either resource local or JDBC connection pools. And what it gives you is a number. It collects a number of metrics that you can then use and integrate into your application performance monitoring tool, and then you can tell, for instance, how the connections are used and what's the dynamics behind them, and what's also offering beneath that is not just the metrics, but you can start from one connection, and then when it sees a timeout, when it catches a timeout, it can increase the connections on demand. So somehow you can start from one and give it an overflow of 5 and see where it settles. So if it settles for 4 or 5 connections, then you know what's the size. So the size is determined dynamically, because otherwise there is no one single mathematical equation which you can use. There is a branch of mathematics called queuing theory. However, that applies mostly. Some of the laws are universal, like Little's law, but for example, others, which are Erlang formulas, are only applicable for systems that are well known and fixed with given latencies, like for example telecommunication systems. But that's not usually the case for software systems, because the response time, especially from the networking side, is not fixed. It can fluctuate. The network always can fluctuate, and that's why you cannot apply those formulas. What you need to do is to apply a feedback mechanism, like for instance FlexyPool. So what metrics does it give you? For example, here you can see the concurrent connection request. What's interesting about this is that when you're doing monitoring, the average doesn't tell you almost anything. If you look there, the average is the orange line at 0.5 connection, which doesn't tell you anything. What you're really interested in is in the whole histogram. The percentiles, especially the 95, 99 percentiles, because those gives you for example, the 99 percentiles gives you the response time that affects 99% of the users. So usually that's where you want to focus, because that will it will apply to the vast majority of the users. But you're also interested in spikes, and only with percentiles you are going to see the spikes, because with the average they are going to be leveled. So when you're collecting metrics, always keep in mind that histograms are very, very important to collect. Also, you can see how the pool size grows, and it settles to 5 connections. So in this particular use case, you know that you don't have to give more connections than that. Also, you can see how much it takes to acquire a connection, and if you have to step in, because the connections are growing, but they wait for a timeout. You can see spikes in those, so you can take some adjustments. And also, one very important metric is how much the connection are leased. And in this particular case, you can see at the end one transaction which took 35 minutes. What's very concerning about that is that if you have many connections or many transactions like that, they are going to keep the connection busy, and other threads are not going to use them. So actually, you are going to do much less of a progress with the application. So yeah, think about it. Always, like when you want to decide something, especially in enterprise, you always want to drive those decisions based on some metrics and measurements, and if you don't have those, it's going to be very difficult to say, like for instance in this case, just pick a number for the connection pool. Okay, so that was about connections. Now another thing is very important, because it's one of the first things that you need to think of when you're using JPA or Hibernate, what identifier generator you want to use. The reason why yeah, this is important, because every entity must have an identifier. That's the way it works, because entities are stored, like for example in the first level cache, it's just like a hash map where you have a key and the value. The value is the entity, and the key is formed of the type of the entity and the identifier. So you have to know that. So you have to choose between either you have an assigned identifier or you have a generated one, and you have multiple choices like identity, sequence, and table. And why I want to show you this is because table performs very, very badly. It's one of those things that sounds very well in theory, but then in practice you'll realize that it's a very, very bad idea, and we'll see why it's the case here. For instance, for identity, The problem is identity is that, for example, in Hibernate, if you choose it, it will disable the JDBC batch inserts. That if the bottom line here is that if your database supports sequences but also identity, it should always pick sequences, not identity. The only thing where you cannot make a choice is with MySQL or MariaDB, where, for instance, it's better to use identity than to use the table, as we will see. The sequence is a separated object that lives in the database. The identity is linked to the table, but the sequence is completely separated. It's a non-transactional object that gives you monotonically increasing sequence values. The problem is that every time you need to insert an entity, you'll hit the sequence and it will generate a new value. So there's some room to improve that. If you're, for instance, if you're inserting 100 entities, you don't want to go to the database with an extra 100 round trips for the sequence value. So you can optimize that. And Hibernate offers some optimizers like high-low pooled and pooled low. And those high-low was used before Hibernate 5, but nowadays in Hibernate the enhanced identifier generator are activated. Or if you're if you're stuck with an old version of Hibernate, you might want to turn that property to true to benefit from the pooled and pooled low optimizer, which otherwise you couldn't do. And for instance, yeah, if you measure the impact, for instance, when saving 50 rows and juggling with the sequence increment size, you see that if you reduce the number of round trip, the response time is going to decrease. So it's this is very important when you're doing batch processing, when you're doing heavy writing. Also, so that was identity and sequence, and now the table. The problem with the table is, when you think about it, it tries to emulate a sequence, but it tries to do it in a way using whatever database offers you. And for instance, the way the sequences work, they are non-transactional. The only way to do that if you're not using a sequence is to try to use a separate transaction. But then if you think about it, a separate transaction means a separate connections most of the time. So you're also putting pressure on the connection pool. And also you need to synchronize to make sure that you're always increasing the sequence value monotonically. So you also have to use some locks. So in this way, when you think about locks, like in Dimitri's presentation, you'll probably instantly kick in and you'll see the term contention. And when you have contention, you can it can affect the way you parallelize. So yeah, the table trying to emulate the sequence also have these optimizers, but as we will see, it does not contradict the fact that you're still having to use those locks. So for instance, even if you're using the optimizer, you'll see that the response time will decrease, but this time, if you're taking a look on the vertical, you'll see that we're talking about milliseconds, which is, so for instance, it takes around 600 milliseconds to call, even to call one time to go to the database with the table. So now what we want to do is to see how they perform, the identity versus the table. That would be the case in MySQL, because in MySQL you don't have sequence, so you have to choose between those two. So if you're inserting and doing a comparison between them, you will see something like that. When you have few threads, you'll not see much of a difference, but the more threads are involved, the more the role of locking and the contention is going to play a role. And what you're seeing here is Amdahl's law, or universal scalability law, where it says that the more contention you have, the less you are going to parallelize. So yes, in MySQL, if you're using MySQL, you probably want to stick with identity, even if it disables the JDBC batch inserts. Now, you have to pay attention to auto, because if you're using MySQL, by default, auto will not fall back to identity. From Hibernate 5, it falls back to table, so pay attention to that, because otherwise you will use the table generator, which doesn't behave very well. Now, when you compare sequence and table, of course, because sequence is something native and table is trying to emulate it, it's even from the beginning you can realize that something that you emulate will never perform as good as something that's native. But just for the comparison's sake, it looks like that. You can barely see the sequence. The response time is very, very low. It's actually below. You can count it in microseconds, in 500 microseconds or stuff like that. On the other hand, the more threads you have, the more the performance bottleneck is going to be of the table. So yes, if you have to make a choice, choose sequence. If you cannot use sequence, use identity, but never use table. Okay, so now we can go further for relationships. Now here it's very easy to visualize them in a single picture, which tells a lot. I divide them in efficient, less efficient, and the least efficient relationships. The reason why there are so many of them, because from a database perspective there are only three. You can have one-to-one, many-to-many, and one-to-many. But why do we have so many of them in JPA? It's because you have bidirectional association, and you can have also unidirectional association. So then you can have, of course, many-to-one and also one-to-many. And then you can have them unidirectional and bidirectional ones. The rule of thumb is like that. If you're going the database way, the way that the database are designed with foreign keys and always use many-to-one or one-to-one on the client side, it's always going to be very, very efficient. The most efficient association are the ones that are based on many-to-one or one-to-one on the client side. Then, when you move away from those, you are going to get from very good to worse, or even or even the worst. So for instance, if you want to use a one-to-many association and you really need a collection, because it's not mandatory to always use collections. Just because you have this feature, sometimes you don't even need it, because you can achieve even better with a query. But if you really have to use a collection, the best performing ones are the mapped by ones, the bidirectional ones, because they are based on a many-to-one on the other side. For the one-to-one, the best one is the one-to-one if you combine it with maps ID, because then you can have a single column that does both the primary, plays the roles of the primary key and the foreign key, so you don't have to have both separated, which will put pressure on the index and on the memory, because it will double the footprint on the index. And for the many-to-many, if you're using sets, the many-to-many JPA notation is fine. Otherwise, you just map the intermediary, the join table as a separate entity, and use many-to-ones and one-to-ones on the other side. Then the less efficient ones, if you really need to use unidirectional collections, then you should know they will never behave as good as the bidirectional ones. But you can still try to optimize them with join columns, or for example, if you're using a set, or if you're using an order column. But they will never be as effective as the one-to-many mapped by ones. And the least efficient ones are the ones which in Hibernate are called bags. And for instance, the one-to-many bag unidirectional association, why is it performing very well, very bad, is because, for instance, if you're trying to remove something, it will just remove everything and re-add everything back. And that puts, not only that it generates much more statements than necessary, but then it has impact also on the indexes, because when you delete everything, it has to recalculate the data in the index, and then you put the data back, it will have to do the same thing with the indexes. So it does a lot of processing that otherwise, which is unnecessary. And when you're doing unnecessary work, it's going to put a pressure on response time. Okay, now related to batching, one advantage of generating statements in Hibernate is that you can have some optimization which otherwise would require you to change code. And why I'm saying that? Because for instance, if you take into consideration how JDBC use batching, it offers different methods for non-batching and batching. Because if you're not using batching, you have to have a statement and you do execute update for insert, for update or delete. But if you want to switch to batching, you'll have to add to batch and use a different method like execute batch. The problem is that few applications are really developed and right from the start with batching in mind. Usually you'll realize that there's some performance bottleneck related to writing data. And if you're using JDBC and you figure out that you need to switch to batching, you'll have to rewrite code. Well, if you're using Hibernate, that's not a problem, because you can switch from non-batching to batching with just one configuration. You don't have to change anything in your data access there. So you have two things. One is a session factory setting, which applies to every sessions, and then you can override that on a per session basis. That's available since Hibernate 5.2. For instance, if you want to have a global configuration, you can set this property, and then every operation can benefit from batching. So for instance, if you are going to insert 5 rows, it will use a single round trip to the database, and which is going to include 5 sets of parameters. But then you only need one single round trip, so it's always faster than using 5 round trips. So if you want to override that on a per session basis, you can do it. You just need to unwrap the entity manager to a session, and you can set the session batch size to a higher value. You can even that can be automated. Like for example, you can have an annotation like batch size and define the batch size per session layer, and then have a spring aspect that does everything that's been doing by this method. So you don't have to clutter your application code with these responsibilities, which for example can be very nicely separated and isolated in their own aspects. If you want to make it dynamic, yeah, you can have it dynamic. You can even change it from the middle of the session if you want. Yeah, you have it like that. But usually you want to define it per session, because you have when you're calling a session method, you already know what you're going to do. So usually it depends on what you're, probably if you want to have like a batch processor and still use the same session. But usually you want to try to keep the session as low as possible, because otherwise it will just grow and it will put pressure on the JVM, on the garbage collector. So usually you don't want to have that. Usually you want to keep both the session and transaction as small as possible and reuse them as fast as possible, so to allow others to do work as well, you know. So now related to batching, when you are going to use batching, you are going to see logs like that. That's taken from DatasourceProxy, that framework that I mentioned when I mentioned the DatasourceConnectionProvider. Well, it's just parsed on multiple lines. So you see, as you can see in this slide, it tells you that you are using batching because the batch is set to true. You're seeing that you only issued only one statement. The query size is 1, but then the batch size is 10 in this case. You see the statement, which has bind parameter values, and then you see all the sets of parameters that were sent. So instead of issuing 10 inserts, one after the other, you just issue 1, and you group all the parameters, and that's going to be faster. How faster is going to be? Something like that. So for instance, if you're inserting 5,000 entities, and by default you are on the left side with 1 because you don't use any batching, you'll see that it takes much more to do 5,000 round trips instead of just use, even if setting the batch size to 10 is going to have a huge impact. And why that? Because instead of 5,000 round trip, if you're using 10, you reduce it to 500. So you saved like 90% of the time. So that's, but then if you try to increase it to 100, you'll see you reduce from 500 to 50. So you're not going to see that much of a gain. Usually, what's the best size? It's said that somewhere between 10 and 30. Usually, it's a very good way to set the batch size. But like most of the time, it's better to measure and drive that conclusion through measurement. And that was for insert, but that's the same also for update. When you're doing a lot of updates to the database, if you're having a batch processor that does a lot of heavy writing, you want to have the batching enabled. And also for the delete, it works just the same. Only one thing that I want to mention here: prepared statements always respond better to batching than simple statements. So keep that in mind. Not only that they provide you protection for SQL injection, and also you can reuse the execution plan, but also they respond better to batching. So keep that in mind if you're using manual JDBC. If you're using Hibernate, you don't have to worry about that, because Hibernate by default only uses prepared statement. The only place where Hibernate uses simple statements is if you're auto-generating the schema, which is only meant for testing. It's not meant for production systems. So if you take that into consideration, you can say that almost always Hibernate is going to default to prepared statements, which respond much better to JDBC batching. Yes? Oh, I cannot tell you which ABCD. Doesn't even matter what databases we are talking about. Why does it? It doesn't matter, because what's the purpose of this slide is to see the relative improvement that you get. In reality, you cannot base your decision based on just one slide in a presentation based on your database, because you need to do the measurements yourself. It takes into consideration the database version, the driver version, how your data access patterns is so complex that you cannot just drive it from a single article that you read and say, okay, this is, and then you can take some decision which are not really not really correct, because if I told you which are the databases, you see, aha, this database is much better because I've seen on this slide, so I should never use the other one, which is not correct, because each database is meant to be used in some particular context. For instance, MySQL is very good for web, but not that much in analytics, or for example, if you're doing finance stuff, but then Oracle is very good for that. So yeah, the decision is much more complex than just some micro benchmark that you can run. So yeah, what's important is to just see from one, if you're increasing the batch size, it's important to see that you gain. How much you gain, you can measure in your application, but there is always going to be a gain. And if there is the possibility to have to reduce the response time, then it makes sense to apply that optimization, and you should take that into consideration, of course. Now, if you're using, it's not just that setting. Once you set it, it's fine. It will work for every use case. But there's only one catch. If you're using cascading, and you insert parents which will cascade to children, and then you also to parents, because you switch from one entity to the other, the batch has to be flushed. So in this particular case, only the child will benefit from the batching, not the parents. What you can do is to set those configuration parameters to true. It doesn't really make sense to set them to have them to false like it's by default. The reason why they are is because they were set like that like 10 years ago, when probably the CPU was much more important or had a much important impact on performance than today. Most of the time, most of the issues are related to disk access on the database server, so probably you want to benefit from batching, even if it means that you have to reorder statements, which is not even that much of an effort for many processors nowadays. So you want, if you set the batch size, set those to true, because they are very, very important for cascading. Okay, and if you're using old version of Hibernate or some old version of the Oracle drivers, you will see that before, like many years ago, if you're using optimistic locking and batching, they were not really working very nicely together, because the driver could not tell the exact update count when you're using batching. And for that particular reason, the optimistic locking mechanism would just complain that something wrong is happening, which sometimes was not even the case. So by default, in Hibernate 5, they are enabled now. If you're using the old version of Hibernate, you might want to set that to true as well, because that's only an issue for Oracle, old Oracle versions, and if you're using some other database, that might not even affect you, so keep that in mind as well. Okay, so now we're going to fetching, because that's probably one of the most important thing when it comes to performance, because most of the problems that arise when you're using a database are based on the fact that you can fetch, and you fetch more than you need. You're doing extra work than you don't even need to do, because it's so simple to do it, especially if you're using frameworks like JPA Hibernate. It's very easy to select a lot of data, and it will not look like a big problem on your development machine, but then when you move to production and the number of data increases, you will start to realize that it's becoming much more of a problem, and it has a much bigger impact. So now, related to fetching, there are multiple things that we can discuss, like for example the JDBC fetch size, the result set size, when it's good to fetch DTOs, when it's good to fetch entities, and also the association between the entities plays a very important role when it comes to performance. So now the first thing that we can discuss is the JDBC fetch size. That's the thing that's defined by JDBC. You can set it at the statement level, and it says, it gives you the number of round trips that are necessary to fetch a given result set. why is it important? For instance, when you're using JPA and Hibernate, because Hibernate will materialize the result set every time. When it returns the query, it will always return a list of DTOs of entities, but the result set has been traversed from one side to the other and it was closed, so all the data has been selected. So yes, the number of round trip counts. Now based on the database that you're using, that can be a problem or not. For instance, if you're using Postgres or MySQL, by default it will fetch the whole result set, so the fetch size doesn't really matter in this case. If you're using SQL Server, they adapt the way they do the buffering, so it doesn't, you don't have to set it because they will find an optimal way of fetching the result set. But the only place where it really matters is if you're using Oracle, because if you're using Oracle, the default fetch size is only 10. So if you select, like for example, 100 rows, it will have to go with 10 round trips to the database. So Hibernate offers one way. You can set it manually, of course, but you can also set, for instance, raise that particular value on a per session factory level with just one configuration, and then from 10 you can increase it, like for example, to 100. But you can also do the same if you want per query basis. There's a query hint called fetch size. Then this one will have precedence over the session factory settings, so you can control it for every query if you want. Now, does it play a role? Yes, of course, it plays a very important role. For instance, here we want to test what's the impact of fetching 10,000 rows, and we see that if we have 10,000 round trips, like the fetch size of 1, it takes a lot of time. Then if you decrease it to 10, it's a great improvement. Then even for 100, there's a great improvement. So for Oracle, you'll probably be somewhere where it's 10. So if you increase it, you will see a gain. So keep that in mind. If you're using Oracle, you probably 10 is quite a bit low. So you might want to increase based on your access patterns. But now think about it. Here I was talking about 10,000 rows. Why would you want to fetch 10,000 rows? It doesn't even make a sense to fetch that much data. Because for instance, if you have a UI application, like a front-end application, then you can display just as much data as you see on the screen. If you have tables, trees, or whatever UI component you're going to use, you can never display 10,000 rows. So you always need to paginate or just display only a part of that data. Now, if you take into consideration that you have mobile clients, which are sometimes on the data and on GPRS, so that will cost you even more money to fetch a lot of data that you don't even need. So yeah, sometimes it even affects. It has a say also on how much money you spend. So yeah, most of the time you don't need to fetch that much data. You just need to fetch just as much as you want to display on the screen, and that's for the UI. But also that applies also for batch processors, because even for batch processor, it's much easier if you roll the transaction one after another instead of fetching millions of entries from the database to the application to do the processing. If you can do that in the database without having to move all that data, it's even better if the database gives you support for that. Otherwise, if you still need to do the processing on the application layer side, it's much better if you're doing in chunks and keeping rolling, because then you can even parallelize it. So instead of having a single thread doing all the processing, which will take that much time, you can split the processing and use multiple chunks and operate in parallel. So in the end, you are going to finish much faster than if you were using a single thread. So yeah, pagination is very important. A very important concept. You should keep in mind that if you're issuing a queries, usually you have to use pagination, because otherwise you'll fetch just as much data that there is on the database. And when you start and implement a feature and you test it on your machine, there is probably going to be a very small amount of data, but then the application will be in production and data will accumulate, and then the performance is going to get worse and much worse, and then you'll have to step in and probably do that. So it's better to think it right from the beginning and apply pagination. What's nice about Hibernate is that you can use those set first and set max result, and they also work both for entity queries and even for native SQL queries. So yeah, Hibernate will wrap the whole query and append the pagination, the paginate based on database specific, using the database specific terminology. So this is the difference. What's the difference between fetching 100,000 and 100 rows? So you see that there's a very, very big impact between those. So yeah, if you only need to fetch 100 rows, just fetch 100 rows. Don't fetch all of them and then discard them in Java. Like for instance, just split the collection, yeah, or filter them, which is it's so easy now with Java 8 to just do it, because when you're looking in the code in Java, it's going to look so nice, but when you're looking on the database side, it's not that nice anymore. So yeah, if you have to use pagination, Hibernate offers the implementation is called offset pagination. It's good as long as the result set and the data that you need to scan is not that much. But and even if you have to only scan the first pages, it's not going to be that bad. The more you're going to the end of the result set, if you have hundreds of thousands of records there that you need to move, the more is going to do a lot of work that is going to discard just to give you that particular page. So it doesn't scale that much for a very large result set that you need to paginate. So in that case, you need to use key set pagination. You can read more about it on that side. Use the index loop. We have Marcus here. He's the author of the of this site, and also he has a book about it, SQL Performance Explained, which is it's very good to read by every developer that has to interact with a relational database. So yeah, keep that in mind. Offset pagination is good, but it has some limitations. If you bump into those limitations, then keep in mind that there is a solution to that. You can use key set pagination. Hibernate does not offer support for it, but you can also use native SQL queries to just use it. Or there are frameworks that offer it, like Juke or Blaze Persistence or other frameworks. Just because you use Hibernate doesn't mean that you cannot combine it with other frameworks. That's some people just limit themselves to only one framework, but it's not the case. You can combine and get the best of both framework if you want. So yeah, now related, this is a very interesting discussion, because when you're using JPA and Hibernate and entity queries, you are going to select everything. Most of the queries are going to look like the one on top with select everything from, and then you can have one or even multiple tables. That's going to, pagination was about limiting the size of the result set when it comes to the number of rows, but then you can also limit the number of columns that you fetch. So in a way, it's like a spreadsheet in Excel. If you want to have good performance, you have to take into consideration both dimensions, both on X and Y. So selecting all columns versus selecting a custom projection can have a very big impact. Like something like that, you can barely see when you select only one column versus selecting, in this case, were like 6 or 7 columns. So it plays a very important role. So the rule of thumb is something like that. If you only need entities if you need to modify them. If you don't modify them, there's no reason why you should fetch entities. You should fetch a DTO projection. I've seen it something like that when people were fetching entities and then using Dozer to create DTOs. Don't do that. Just fetch DTOs right from the very beginning. It's like you fetch a lot of data and then you funnel it and then you reduce and throw everything away just to only send one small subset of the data. And think about it, because you're moving a lot of data, extracting from this, putting on the network, then it becomes in the memory of Java. You put pressure on the JVM, and then you take that and you have to serialize it, transform it to JSON, send it again on the network to the client. You do a lot of work, and if you don't reduce the result set to just as much as you need, you are going to lose on two times on the networking, on the disk, and also processing JVM. So it will just add up and add up. So yeah, try to reduce both the number of rows and also the number of columns. So now, related to DTO projection, when they are good, they are very good for read-only views. When you only want to, for example, when you're building queries, tables, which you don't really need to modify, because when you want to modify, you will probably hit on a button which says edit, and then you will load each particular entity, which then can be one entity which you want to modify, because then you can benefit from things like dirty checking and benefit from the thing that Hibernate offers to you. Other use cases where a DTO projection makes much more sense than one entity is, for example, when you want to benefit from things that the database will offer and otherwise you will not have them in JPQL, like for example window function, recursive, common table expression, pivot, or any other feature that goes beyond from the way JPQL can offer you. Now entity, as I said, if DTOs were very good for reading data, entities are very good for writing data. Why? Because you can benefit from the dirty checking mechanism, but also from the versioning and the optimistic locking mechanism. You can also achieve application level repeatable reads, so that you don't lose updates across multi request logical transactions. Now, last thing about fetching is about relationships. By default, many-to-one and one-to-one are using eager. That's very bad. Don't use that. Don't use the default way. Always set everything to lazy. And then, why that? Because the only way when you have the right context of what you want to fetch is on the query and on the service method basis. You can never know during the mapping, the global mapping, and give one solution that works for every particular use case. That's why eager never makes a lot of sense. Not to mention that when you use eager, you can easily bump into n+1 query issue without even realizing if you forgot to join fetch them into an JPQL query. Now, there are also the reason why they are eager. They used to be lazy before JPA. The reason why they are eager is just because when JPA 1 emerged, they thought that proxies should be just optional. In reality, they cannot be optional, so that was quite a bad decision. So yeah, don't use eager because they are bad. So yeah, you should always use lazy and override the lazy on a per query basis. The reason why it's good to have them lazy is because you can always turn a lazy into a eager. The other way is not possible, even if you have entity graphs which said that work. They don't work like that in Hibernate, because lazy is just a hint. So now when you use lazy, you will inevitably bump into that lazy initialization exception issue, which has good ways and bad ways to solve. The best way is to just use join fetch with it and fetch just as much data that you need, or even use a DTO. There are also bad ways, like this one. Some call it pattern, but it's not. It's an anti-pattern. Why is it an anti-pattern? It's because the moment when here, the only thing that's transactional is what you have in the service layer. Then when you keep the session open and you keep on issuing queries by the UI, what happens? You are going into auto commit mode, so you put a lot of pressure on the connection pool because you release, and you get a connection and then you release it back. And also if you're not using read-only optimization and stuff like that, it will write into the transaction log for each one of them. So yeah, that's not really a pattern at all. What you want to do is when you exit the service layer, you have to have everything sorted out and just fetch everything that you needed. It's not that the UI should never drive and generate more statements then, because you have much less control than if you're doing the proper way. So don't do that. Now there is another trick. I don't know if you know about this property. If you don't know about it, that's a very good thing. If you use it, don't keep it to false like it's the default. Now you will probably see, if you search on Stack Overflow like solution for lazy initialization, you will see an answer with 60 votes for use that. That's bad. Don't always take everything you find on Stack Overflow. Sometimes you have to question everything, even what I'm telling you today. So yeah, always question everything that's been given to you and put in context. That's not very good. Why is bad? It's practically the same thing that does Open Session in View. Actually, it's even worse than Open Session in View because you create a session and you don't even reuse the session. So you keep on creating session, which also puts pressure on the number of objects that are being created. So yeah, don't use this temporary session anti-pattern. Now the last thing on our agenda is related to caching. Now when it comes to caching, there are multiple flavors of caching that you will have in an enterprise application. One of the most important ones is the one on the database side. Unfortunately, it's much of the time is overlooked. It's the way the shared buffer in the database. The database have evolved in such a way that they can take advantage of RAM and do a lot of operation in RAM. They don't have to go to the disk. If you optimize that, you can gain a lot of performance, and yeah, you can cache because the working set can be in memory, so in a way that will operate like a cache. What's good about it is that it's highly consistent, so you don't have to worry about consistency issues. On the other hand, the more you move away from the database, the more performance you're going to gain, but it's going to be much more difficult to maintain consistency because you're going to be because you lose contact with the database and things can change in the database without you knowing. So yeah, there's a balance between consistency and performance. So in a way, you need to have both. You need to tune the shared buffers on the database, but most of the time you would probably want to have some application level caching solution to make sure that a given traffic spike is not going to put your database, is not going to put to affect the database. So probably you want to have that as well. And most of the time you're denormalizing the data, because if you're using a full text search, you're still denormalizing the data, so that's not much of an issue. Not everything needs to be extremely highly consistent. Now, the second level cache has an applicability. It's very good for one particular use case, as we will see. It's somehow in between, because it can give you good consistency while still giving you some performance optimization. The reason why where it really makes sense, because it doesn't make sense for every use case. If you're using only for read-only queries or for read-only data, then you're using it wrong, because that problem is already solved by database replication. You can always span more and more slave nodes and increase the read query throughput, so you don't really need the second level cache for that. What's really important, where it's really important to use is on the master node, when you want to offload the queries on the master node, because you still want to maintain consistency. So that's exactly the place where it really makes sense. The reason why it makes sense is because cache invalidation is a very complicated topic, and the second level cache does it for you, so you don't have to deal with it. And the second level cache offers multiple levels or modes or strategies. Some of them are consistent, like for example read, write, or transactional. Transactional is using JPA, so it has some performance, it has some impact on performance, but then read, write is a very good default if you want to use it, because it uses some soft locking mechanism, which doesn't imply and doesn't incur the penalties of JTA, but still provides consistency. The non-stick read write is it has a very slight inconsistency window, so keep that in mind. And read only, well, yeah, that's read only is not very applicable, because if data is read only, you can just store it in Redis or memcached and then just query it from there like an aggregate. So another thing, that's the query cache in Hibernate is not very useful. What's really useful is the collection cache. You can have the entities and the collection cached together. The way it works is that it simply caches the identifiers of the children that are saved also in the cache. What's nice about it is that just like the cache for entities, it offers you strong consistency, and it can address a problem like that. For instance, you can have a whole aggregate stored in a cache. Like for example, here we have a post with counters, page views, user votes, comments, and tags. And if you store something like that in memcached, and then you change the name of a tag, then it will probably affect like hundreds of thousands of entries, which you'll have to update, and that's bad. The reason why it works nicely in Hibernate in second level cache is that those are normalized, those are split in multiple regions, so once you modify only a single entity, it only affects only one single entry. So even if it's split in multiple regions, you can still fetch the whole aggregate from the cache. You don't have to go to the database. And that makes sense, exactly like I told, on the master node, because you want to have that fetched because you want to modify it. So you want to be on the master and on the read-write transaction. So that's exactly where the application level, the second level cache really shines in this particular use case. So now we went through all of those. Now we have some, I think we have some time for questions and answers, so please ask them if you want.